Dear student, in this video, I am going to share the next part of aliphatic nucleophilic substitution reactions. In previous video, we talked about what is substitution reaction, what is nucleophile, what is nucleophilicity, what are the different types of solvents. So the preliminary idea now you have what is aliphatic nucleophilic substitution reactions. Now, in aliphatic nucleophilic substitution reactions, we have to discuss three important reactions, SN1, SN2, and SNI reaction. In this video, I am going to share some part of SN1 reactions. So here, in SN1 reactions, we have to cover, first of all, the general reaction of this, then the kinetic of this reaction, mechanism of this reaction, the 3D animated SN1 reaction, and the structure of carbocation, the energy profile diagram, stability of carbocation, stereochemistry of SN1 reaction, ion pair mechanism in SN1 reaction, and effect of solvent in SN1 reactions. So these 10 points we have to cover under the heading of SN1 reactions. In this video, I am going to discuss the first 5 points in part 1. So let us start for the discussion of SN1 reaction with general reaction. Now, what is the meaning of SN1? S stands for substitution, N stands for nucleophilic, and 1 stands for unimolecular. What is general reactions? So, in general reaction, this is a tertiary butyl bromide. It reacts with water molecule, and the product of this reaction is tertiary butanol plus HBr. So this is a general reaction. Water molecule in this case acts as a nucleophile, and as it is having only unshared pair of electron, there is no naked pair of electron. Therefore, this nucleophile is a weak nucleophile. This Br is the leaving group, and this tertiary butyl group, that is the more, or we can say a hindered carbon. The reaction takes place on more hindered carbon. So this is overall the nucleophile attack on aliphatic carbon atom. Therefore, it is called as a nucleophilic substitution reaction at aliphatic carbon atom. Now, what is the kinetics of this reaction? What is the meaning of kinetic of the reaction? How we define the kinetic? So kinetic is what? It is deals with the study of rate of reaction. So the rate of reaction is proportional to the concentration of reactant only. So as the nucleophile not plays role in a rate determining step, therefore the rate of reaction depends only on the concentration of only on the concentration of reactant or the substrate. The reaction follows the first order kinetics. That means the rate of reaction depends on only the concentration of reactant. This is indicated by the rate expression. Rate is equal to K. K is the proportionality constant into bracket, that is the concentration of reactant. And here the reactant is tertiary butyl bromide. The rate of reaction depends on the slow step of the reaction known as rate determining step. Bond breaking is always a slow step and it requires the heat, so it is an endothermic process. While bond formation is fast and it is the exothermic process. So overall, the kinetic of this reaction is the rate of reaction depends on only the concentration of the reactant and not the concentration of nucleophile. The role of nucleophile that we can see in the second step. So second step, as the second step is the fast step, therefore the rate of reaction not depends on the nucleophile. Now, what is the mechanism of this reaction? So look at, it's a tertiary butyl bromide. The first step is there is a development of charges. As Br, it is more electronegative atom. So Br, there is a partial minus sign, and this carbon, there is a partial plus sign. So due to this development of charges, the bonding electron pairs are shifted towards Br. So the carbon Br bond, CBr bond is going to break in the first step. So this bond breaking is a slow step. So because of that, this step is the RDS. So first step of this reaction is RDS. So this is the first step. So overall in SN1 reaction, there are two steps. In first case, we call it there is a departure of leaving group. So due to this departure of leaving group, there is a formation of a carbocation. So carbocation is formed. Carbocation, it is sp2 hybridized carbocation. Therefore, the geometry is trigonal planar geometry. Because of this geometry, now in the second step, so this is the second step. In the second step is what? Now here the nucleophile plays role. In the second step, the nucleophile attack on the carbocation. So nucleophile having an unshared pair of electrons, so it attack on this carbocation. Same, it can attack on this carbocation. Now here there are two options. The nucleophile can attack on the carbocation from backside, as well as the nucleophile can attack on the front side. So because of this, as this is a planar carbocation, therefore there is a equal chances of attack of nucleophile from backside 50% chance, and from front side there is a 50% chance. So because of that, we get this product. But as it is not a chiral carbon, therefore these two products are one and the same. But if this carbon is chiral, then we'll get the two different enantiomers. So this is the mechanism of reaction. The first step of SN1 reaction is the rate determining step. Here there is a departure of leaving group. So look at how many steps are there. So there are two steps in SN1 reaction. The first step is the departure of leaving group. The result of this is the formation of carbocation. And as I already explained, the bond breaking is the slow step because it is a endothermic reaction. Therefore, we call it a slow step, and slow step is always the rate determining step. It is called as RDS of the reaction. The carbocation is stabilized by electron donating effect. Why the carbocation is stabilized by electron donating effect? As you know, carbocation, there is a development of positive charge, and due to the positive charge, if the groups which are attached to the carbocation, if they are electron donating group, then that group donate its electron density towards this cation. Because of that, there is a delocalization of positive charge. Whenever the charge is delocalized, that structure is always stable. So for the stability of carbocation, the electron donating groups are needed. What is the second step? The second step is the nucleophile attack on the carbocation. So as the nucleophile is the water molecule in this reaction, and there is unshared pair of electrons, so nucleophile is a weak nucleophile. As carbonium is sp2 hybridized and its geometry is trigonal planar, so there are equal chances of attack of nucleophile from both the sides, that is 50% chance for attack of nucleophile from front side and 50% chance for attack of nucleophile from back side. So the second step is always the fast step because the carbocation is a charge structure. It gets collapsed into the product, and product is the neutral molecule. So neutral molecules are always more stable. structures as compared to the charge structure. So whenever we are going to move from unstable structure towards the stable structure, then that step is always fast. The carbocation is the charge structure and the product, there is no charge. So this type of process is always a fast step. So you can see in the first step, what happened in the first step? The reactant, there is no charge in the reactant. A complete positive charge or complete negative charge is not there in the reactant. Partial charges are there. So reactant changes into the formation of carbocation. So reactant, there is no charge, but in carbocation, there is a positive charge. So moving from stable, no charge structure towards the unstable charge structure, that step is always the slow step. So first step is the RDS in SN1 reaction, while second step is the fast step. So rate of reaction depends only on the reactant because the nucleophile not plays role in the first step. So it is called as a one, that is rate of reaction depends on only one molecule. Therefore, it is called as unimolecular reaction. Now, here, how the reaction takes place. So in this case, the leaving group departs, and because of that, there is a formation of a carbocation. Once a carbocation is formed, now you can see this one is a planar carbocation. Therefore, the nucleophile or the incoming group can approach from, now in this case, it approaching from the left side. Now, the second possibility is once a leaving group departs, then the formation of carbocation. Now, here the incoming group approaches from the left side. So, there are the equal chances of attack of nucleophile from both the sides. So, this is the SN1 reaction. Now, the next one is the structure of carbocation. So, just now it express that carbocation is sp2 hybridized, therefore its geometry is trigonal planar. So you can see here that the leaving group, when the leaving group departs, and then there is a formation of carbocation. So you can see here there is a plus sign. So there are the development of empty or the vacant p orbital. So these are the vacant p orbital. So because of the development of positive charge. So we call this is a carbocation, and carbocation is the planar one. So the angle initially in tetrahedral, when the reactant is tetrahedral, that is sp3, in sp3 the angle is 109 degree 28 minute, and in sp2 now the angle changes to 120 degree. So now here angle changes to 120 degree, and because of that, as the carbocation is planar, therefore there are equal chances of attack of nucleophile either from front side or from the back side.